All right, Chapter 4, Wave Shaping. Non-resident training course, September 1998, Navy Electricity Electronic Training Series, Module 9, Introduction, Wave Generation, Wave Shaping, Navy, Navi, Trod 14181. Approved for public release, distribution unlimited. Chapter 4, Wave Shaping Learning Objective. Upon completion of the chapter, we'll be able to explain the operation series limiter circuit, explain the operation parallel limiter circuits, describe the operation dual diode limiter circuit, explain the operation clamper circuits, explain the composition of non-sidule waves, explain how RC and RL circuits are used with the integrators, explain how RC and RL circuits are used with the differentiators. Explain the operation for the counting circuit. Explain the operation of step-by-step counting using the frequency divider and limiters. The technician from the U will be confronted with the different limiting circuits. The limiter circuit is defined with the device which limits some part of the waveform from exceeding the specified value of the limited circuit. This is primarily wave shaping, the circuit protection and application limiter. A little more than half a wave rectifier start with the Neets Module 6 introduction to electronic emission tube and power supply. By using diodes resistors, sometimes with a DC bias of the voltage, you can be built with a limiter that will eliminate the positive negative alteration for an input of the waveform. Such that the circuit is also a limited portion alterations to be specific with voltage. In this chapter, you will include the 5 type of the limiter: series positive, series negative, the parallel positive, parallel negative. Dual diode limiters, both series with the parallel positive and negative limiters, use the bias to obtain the circuit certain wave shape that will be discussed in this chapter. The diode and these circuits will alter the limiting component of the polarity location will respect with the ground of the factors determine the circuit action. The series limiters of the diode and series of the output of the parallel limiters. Parallel limiters of the diode is parallel with output. Series limiter. You should remember that the Neets Module 7 introduction solid state device and power supply with the diode will conduct with the anode voltage of the positive with respect with the cathode voltage of the diode will not conduct the anode of the negative with respect with the cathode. Keeping the two simple facts in mind with the study limiters will understand with the operation knowledge of the voltage divider against the Neets Module 1 introduction matter energy direct current will also help you understand the limiters. A similar series limiter the diode was connected with the series with the output shown figure review A with the figure 441. The input signal is applied with the cross of the diode resistor for the output is taken across with the resistor series limiter circuit that can limit either the positive or negative alteration depending on the polarity of the diode connection with respect to the ground circuit shown in figure 441. View B is the series positive limiter with reversing diode 1 would change the circuit as the series negative limiter. Figure 4.1 showed the series positive limiter input with the diode going diode 1 going into resistor 1 output giving you the negative alteration of the output. Input and output, series positive limiter, series positive limiter. Look at the series positive limiter output of the figure 4.1, the diode 1, and then see the output of the out taken across the resistor 1. The input must be negative with respect to the anode of the diode, make to the diode conduct with a positive alteration input with the signal with the time interval 0 and time 1 to time 1 applied with the circuit with the cathode positive with respect to the anode of the diode is reverse bias will not conduct the since no current with the flow with the no output is developed with the resistor during the positive alteration input signal during the negative half cycle of the input signal with the time interval time 1 to 2. The cathode is negative with respect to the anode of the cover of the diode to be forward by with the current will flow with the resistor 1 output is developed. Output during each of the negative alteration input with approximately same of the input with a negative 10 volts that must become the most voltage that drops across the resistor and ideally the output wave shape that should be exactly the same with the input wave shape, only with the limited portion removed. The diode is reversed by with the circuit almost with the amount with the reverse current flow shown above the 0 volt reference line in figure 4.2 with the during limiting portion of the input signal of the diode resistance should be high compared with the resistor during the time of the diode conducting the resistance of the diode should be small. So compared to that of the resistor, in other words, the diode should have very front to back ratio forward resistance compared with reverse resistance. Relationship can be better understood if you study the effect of the front to back resistance ratio has a circuit input. 4.2 show the actual output of the series positive limiter. Time interval 1, 2, 3, 4, 0 through 4, over voltage 10, 0 volts is 10, negative 10 volts. With the following formula, you could determine the output amplitude, the voltage output that equal the resistance time over the resistance time, the AC, or the value of the AC resistance of the diode under the forward reverse minus bias conditions equals voltage input. Voltage output would equal the resistance time over the resistance time, the voltage value of the AC resistance times the voltage input. Let's use the formula to compare the front-back ratio of the diode with the forward-reverse bias condition. Resistor 1 has 1,000 ohms voltage. Resistor of the AC 100 forward bias condition. Resistor 100,000 ohms reverse bias condition. Voltage input is 10 volts. Forward bias is equal to voltage output of the resistance over the resistance over the plus the voltage the resistance AC bias amp times the voltage input, which gives you 0.09 volts. Reverse bias is equal to the voltage output over the resistance times the resistance time over the resistance time resistance of the AC times the voltage input, 0.9 voltage. You can readily see the formula comparison. The forward bias resistance conditions show that the small amount of the reverse current will flow during the limited the input of the waveform. The small amount of the reverse current will develop the small power of the voltage with 0.09 volts, shown in Figure 4.2 for the time intervals 0 to 1 and 2 to 3. But the actual amount of the voltage developed will depend on the type of the diode used. For the remaining of the chapter, you will use only the idealized waveform to disregard the small voltage. Series positive limiters with bias. The series positive limiter, Figure 4.1, view A, with the reference point with the bottom with the resistor 1 with the ground is 0 volt, with the placing the DC potential at point 1 with the Figure 4.3 with the view in A, B, with the chain with the reference point with the chain with the amount of the DC potential supplied by the battery. The battery can either aid or oppose the flow of the current in the series limiter. Circle the positive bias adding. Positive bias is aiding as shown in Figure view A, and the negative bias is opposing shown in view B. All right, 4.3, positive negative bias for the positive bias. Show the voltage input going through the capacitor of the diode, back to the voltage input of the diode, and then to the diode 1, the resistor 1 of the diode 2, and the voltage output. All right, your positive negative bias show the voltage 0 volts resistor, voltage go over the resistor diode 1. When the DC A with the forward with the bias, view A with the diode conduct with the normal signal apply with the input signal is sufficient with the positive to overcome the DC bias potential is required a reverse bias to cut off the diode. But let's look at the series positive limit of the positive bias shown with Figure 4.4. View A and B, but the diode will conduct with the input signal to see the positive 5 at 10 time constant 1 with the positive alteration input with the signal with the positive alteration exceed 5 volts. The diode becomes reverse bias with limits of the positive alteration output with the signal to 5 volts. This becomes no current flow through the resistor 1 battery voltage is felt at point B. The diode remains reverse bias until the positive alteration input signal decreases just under 5 volts in the time constant 2 at that time the diode again becomes the forward bias and conduct with the diode will remain forward bias for time interval 2 to 3. During this period, the negative alteration input bias through the diode without being limited from time 3 to 4. The diode is being again reverse bias output is again limited. Figure 4.4 shows the series positive limiter with a positive bias, and also series positive limiter with a positive bias. Now let's look at what takes place with the reverse bias A with the sugar shown in Figure 4.5 with the view A with the diode with the negatively biased with the negative 5 volts of the battery, and the view B with the comparator with the output and the input signal from time interval 0 to 1. The diode reverse bias and the limiting taking place with the output with the negative 5 volts battery voltage during the period with the negative alteration increases toward negative 10 volts at time interval 1. Cathode diode would become more negative than the anode is forward bias at the time interval 1, 2, 2. The input signal is passed. The output of the diode remains forward bias until the negative alteration had to decrease with the negative 5 volts at time interval 2. Time interval 2, the cathode of the diode becomes more positive than the anode, and the diode is again reverse bias that remains until time interval 3. So Figure 4.5a shows the series positive limiter with a negative bias, 5 volts resistor diode input signal output signal negative 5 volts. Series negative limiter. The view A with the Figure 4 sub of the series negative limiter limit the negative portion of the waveform shown with the UB. Let's consider the input signal to determine how the output is produced during the time interval 0 to 1. The UB with the anode more positive, the cathode with the diode conduct the current flow up through the resistor diode with the positive voltage is developed at the output of the voltage across the resistors essentially at the same as the apply for the circuit. Show the your series negative will give you positive output diode resistor, and also show the series negative with the during time interval 2 to 1, the anode is negative with respect to the cathode. The positive does not conduct with the portion of the output. It's limited with no current flow for the resistor. As you can see, the only difference with the series positive and the series negative limiter is the diode reversing negative limiters. Series negative limiter with a bias. View A with the Figure 4.7 show for the series negative limiter with a negative bias with the diode, the forward bias with the conduct with no input signal. With the view B will continue to conduct with the input signal swing for the first bias with the negative, only negative 5 volts from time 0 to 1. Time interval 1 input becomes the negative because with respect to the negative 5 battery bias. The diode becomes the reverse bias with the cutoff of the time 2. But when the anode becomes positive with respect to the battery voltage with the negative 5 volts. The cathode no voltage is developed with the output of the resistor 1 by resistor 1 no current flow, but the output is held with the negative 5 volts from the time to 1 to time 2 for the negative bias applied with the series negative limiter with only a portion of the negative similar limited. Figure 4-7 of the series negative limiter with a negative bias. Okay, no, let's look at the series negative limiter with the positive bias. Figure 4 shown 4-8 view A. But here will be removed with all the negative alteration. Positive, part of the positive alteration input signal will have given the full explanation. Series positive limiter with the series positive limiter with a bias, and series with the negative limiter. Series negative limiter with the negative bias. Therefore, you should have little difficulty understanding what happens in the circuit in the figure. Figure 4H over the series negative limiter with a positive bias. Input with a diode 1, resistor 1, 5 volts. Output is positive 5 volts. Input wave and output wave. Series negative limiter with the bias of the positive bias. The difference one only aspect of the series positive limiter with the bias discussed there. The difference of the diode with its reverse output with the opposite polarity. Parallel limiters. A parallel limiter circuit is also used with the same diode with the theory of the voltage divider action as a series limiter. The resistor and diode that are connected in a series of the input signal with the output signal with develop the curve of the diode with the output with the parallel with the diode with the hint for the circuit name of the parallel limiter. The parallel limiter can limit either the positive or negative alteration over the input signal. Recall with the series limiter with the output with the developer with the diode was conducting in the parallel limiter with the output will the developer when the diode is called. They should not try to memorize the outputs for the circuit rather than you should try to study their action to be able to figure them out. Parallel positive limiter. The schematic diagram shown in Figure 4-9 view A with the parallel positive limiter. The diode is parallel with the output with the only positive half of the cycle. The input is limited with the positive alteration input signal with the supply with the circuit at the time interval 0 to 1. But the diode is forward bias with the conductor of the action. They must be seen with the view B with the current flows up through the diode with the resistor voltage. Drop the curve to each other. Across each. The resistor 1 the much larger for the forward resistance of the diode 1 much more of the input signal to develop the cross resistor 1 with the lead to the very small voltage across the diode output with the positive alteration input signal has been limited. 4-9 show the parallel positive limiter input signal resistor 1 diode and the output of T1 time 1 time 2 the diode is reversed by the axis with the external high resistance. The negative alteration of the input signal with the appears across the diode approximately the same amplitude with the input with the negative alteration input but is not limited. A series limited with the parallel limiter should provide with the maximum output voltage but the unlimited with the power of the signal. Reversed by the resistance of the diode must be very large compared with the series of the resistor determine the output with the amplitude using the following formula. Voltage output is equal to resistance over the resistance, the time the resistance of the AC and the time the voltage input. Parallel positive limiter with a bias Figure 410 view A with the schematic with the diagram. Parallel positive limiter with a negative bias. The diode is formed by over the and conductor the input signal with the diode 1 essential for the short circuit with the voltage output terminal with is negative 4 volts. Alright, show Figure 410 show the parallel limiter with the negative bias. A positive alteration input signal applied with the circuit of the diode remains forward with the bias limits for the entire positive alteration shown in view B, but the signal goes in the negative direction in the output before time interval 1. The diode remains forward bias limiting and still present until the input signal exceeds the 4 volts at time interval 1. Diode 1 becomes reverse bias the anode because of the more negative of the cathode, but the input signal the more negative of the negative 4 volts of the bias battery of the time interval 1 to 2. The diode is reverse bias the remains cut off of the output flow for the input signal of the time interval 1 to 2. But all other times during the cycle of the diode is forward bias the limiting occurs, and the circuit is called the positive parallel positive limiter with a negative bias because of the positive output with the limited of the bias circuit is negative with the reference for the ground. Limiting takes place at all points more positive than negative 4 volts. A circuit shown in Figure 411 the view A with the parallel positive limiter with the positive bias the positive terminal of the battery is connected with the cathode of the diode with the cathode of the diode will be reversed bias with the all type of the except for the input signal the more positive than the bias voltage of the time interval 1 to 2 that's shown in view B. Alright, 411A with a parallel positive limiter with a positive bias, resistor 1 diode 1 4 volts, show for the 0 volts and positive voltage, also input with the parallel positive limiter positive bias. A positive alteration input signal that applied with the time interval 0 with the output voltage flow with the input with the signal the time interval 1 to 2 with the input signal that was more than 4 volts diode and forward bias with the conductor of the time and the output with the equals to the bias voltage limiting takes place from time interval 2 to 4 with the input signal of the diode is reversed bias that does not conduct the output signal of the flow with the input with the signal with no limiting taking place. The circuit is coupled with the positive parallel positive limiter with the positive bias because the limiting takes place in the positive alteration positive bias is within diode. Parallel negative limiter. The parallel negative limiter is shown for the view A with the Figure 412 with the most similarity with the parallel negative limiter. The parallel positive limiter is shown with the view A with the Figure 4-9 with the time interval of 0 to 1 with the input signal with the diode is reversed by but does not conduct the shown with the UB with the Figure 412 with output signal flows it follows the input signal the positive alteration is not limited. Show the input signal positive negative limiter. Resistor diode, I noticed that has a positive output wave. This shows your output parallel negative limiter. During the negative alteration, the input signal time 1, time 2 with the diode, forward bias with the conductor with the relatively full lower forward with the diode 1 develop with a very small voltage, therefore limited the output with nearly 0 volts. Voltage develop across the resistor current flow through the resistor and the diode. Parallel negative limiter with the bias. The circuit shown in figure 413 view A with the parallel negative limiter with a negative bias with no input with the battery maintained with the diode 1. Reverse bias with the condition diode 1 cannot conduct until the cathode is more negative than the diode 1 acts until the up on and the input signal dips and below the negative 4 volts at the time interval 2. View B with the time interval 2. Input signal becomes the negative enough for the forward bias with the diode 1 conduct the acts like a short output limited with the negative 4 volts from the battery with the time 2 to 3. Between time 3 and 2 and 3 and 4, the diode is again reversed by the output signal 5 of the input signal limiting occurs. 413 show the parallel negative limiter negative bias and also the parallel negative limiter with a negative bias. Figure 414, view A with a show of the parallel negative limiter with the positive bias for the operation. Some of the circuit also already being limited, limiting a curve with the diode conduct with no limiting a curve when the diode reverse bias with the encirculated bias battery provided with the forward bias with the diode without any input signal output that does positive 4 volts except for the input goes above 4 volts and time interval 1 and 2 as shown in view B with the part of the signal more negative than 4 volts are limited. Alright, 414 show the parallel negative limiter with a positive bias, 4 volts. Also show the time intervals show the parallel negative limiter with a positive volts. Dual diode limiter. The last type of limiters to be discovered in this chapter, the dual diode limiter is shown in figure 415 view A with the limiter combined with the parallel negative limiter with the negative bias of the diode 1 and bias 1. Parallel positive limiter with the positive bias of the diode 2 and positive bias 2. The bias 2 with the both parts are both of the positive and the negative alteration removed with the circuit each for the battery 8 the reverse bias with the diode within the circuit. Circuit has no current flow with no input signal. The input signal is below the value of the biasing battery with the diode, both diode and diode 1 and 2. Reverse bias of the diode within diode 1 and diode 2. Reverse bias of the output flow for the input signal becomes more positive than 20 volts for the view B with the diode 2 conduct with the limits for the output for the 20 volts. Input signal becomes more negative than negative 20 volts for the diode 1 conduct with the limits for the output for the value than either diode conduct for the output flow for the input waveform. Shows 415 show the dual diode limiter. Show the you have 25 volts, negative 25 volts diode 1, 20 volts, 20 volts, and then diode 2. They are flipped. Resistor 1. Input signal and output signal clampers. Certain applications of electronics require the upper and lower extremity with the wave will be fixed for the specific value of the such application for the clamping or clamper. Circuit is clamping circuit clamp the strain with the upper and lower extremity with the waveform fixed with the DC potential for the circuit is known by the DC current restore baseline stabilizer. Such circuits are used to test equipment, radar systems, and electronic counter measurement systems, or system depending upon the equipment you can find with the negative of the clampers with or without bias. Figure 416 view A through E illustrate the example of the waveforms created without a clamp. However, they will be discuss clampers. We will review some of the relevant points about the series RC circuits. Alright, A show the 416 A show the clamping waveform without clamping. Without clamping, 200 volts, negative 50 volts, 200 volts. Without clamping lower extremity with the wave that is held at 0 volts. And clamping the waveforms with a clamping lower extremity with a wave that's held at 0 volts. Also, the clamping with the clamping lower extremity wave that's held at 100 volts, and also wave clamping upper extremity wave that's held at 0 volts. Clamping wave the clamping upper extremity with a wave that's held at 0 volts. Wave clamping upper extremity with a wave that is held at negative 10 volts, and also series RC circuit. The RC circuit will widely give the coupling of the signal of the one stage with another. As time constant coupling circuit with comparatively along the shape of the output waveform will be almost identical with the input. However, the output of the DC reference will be different from that of the input. Figure 417 view A show for the typical RC coupling circuit within the output reference have been chained with 0 volts. In this circuit, the value of the resistor 1, capacitor 1 is chosen so that the capacitor will change charge during the time interval 0 to 1 within 20% of the applied voltage shown in view B. Within this mind, let's consider the operation of the circuit of 0 to 50 volts of the 1 microfarad with a capacitor 1 million mega ohm output damping square and sawtooth blade RC coupling. Input RC coupling. All right. At the time interval 0 for the input for the voltage of the negative 50 volt for the capacitor being charged with the first input of the voltage for the cross the capacitor is 0 for the voltage for the cross of the resistor of the negative 50 volt for the capacitor charged with the voltage and increase the voltage across with the resistor with the output voltage for the being drop of the voltage across the capacitor increase at the time interval 1. The capacitor has charged with the 20% with the negative 50 volts input with the or 10 negative volts to cover the input voltage for the new 0 volts. The capacitor must discharge the discharge for the low impedance for the signal source through the resistor, developing the 10 volts across the resistor. The first instance for the capacitor discharge 20% of the original 10 volt charge of the time interval 2 to 1, 1 to 2 for the charge, and the capacitor discharge for the 8 positive volts for the output voltage that drops about 8 voltages. At time interval 2, the input signal because of the negative 50 volts, again, the negative 50 volts series, the opposition, the 8 volts charge of the capacitor of the voltage across the resistor is told with the negative 42 volts. Notice that this volt value of the voltage is negative 42 volts smaller for the amplitude of the output wave voltage with the curve of the TO time interval 0 until the negative 50 volts. Capacitor now charge with the 8 plus 8 to 16 power of the voltage, which in continue with the following with the operation circle that will have the finally the output wave shown shape of the will be exactly the distributed 0 volt reference. At this time of the time of the circuit operation will have reached their stable operation point. Note that the output wave shape of the same amplitude with the proximity of the same shape of the input wave side, and now the rods equally above and below 0 volts. Clampers show this of the RC time. And so the input and output waveforms will also be almost identical to shown in figure 2 time interval 11 and 12. All right, positive diode clampers. The figure 418 view A will illustrate the circuit of the positive diode clamp of the resistor 1 provided with the discharge of the capacitor 1. Resistance large enough that the discharge of the time of the capacitor 1 will be along with the compare with the impedance also width of the divide provided with the fast charge of the path of the capacitor 1. After the capacitor 1 becomes the charge of the axis voltage source of the input wave shape of the shown view B. Square waves and varies between 25 volts and negative 25 volts. Compare each of the portion of the input wave shape of the corresponding with the output wave shape of the keep curve soft laws in mind. Algebraic sum of the voltage drop around with the closed loop is zero at any instant. All right, 418 show the positive damper waveform. Resistor 1, capacitor 1, 25, negative 25 volts. Shown in a and the diode. Also show the output and the input signal, and then your output positive damper waveform. At time interval 0, the negative 25 volts input signal across with the resistor 1 and diode with the capacitor short with the valve of the first instance of the initial volt of the resistor 1 and the diode 1 to cover the voltage spike with the output with the recover the charge of the capacitor 1 through the diode 1 almost instantaneously zeroing the pulse of the such with the other only negative effect on the output with the negative 25 volts across the diode 1 make the cathode negative the respect with the anode of the diode conduct heavily with the capacitor 1 quickly charge with the small resistance of the diode 1 with the voltage across the capacitor 1 increase the output voltage increase at the same rate the voltage of capacitor 1 reach with the negative 25 volts of the output is 0 volts. At T1 with the 25 volts already across the capacitor with the 25 volts input signal and the series of the A each up of the series A into 50 volts with the cross of the period with the cross of the resistor 1 and diode 1. At this time the cathode of the diode 1 with respect with the anode the diode does not conduct with the from time 1 to time 2 with the capacitor 1 discharge with approximately 23 positive volts because of the large value with the resistor and capacitor the output voltage of the drop of the devoted 50 volts to 48 volts. At the time 2 the input signal change with the 25 volts to negative 25 volts. The input signal input is now series opposing with the 23 positive volts across the capacitor 1 that leaves the output of the voltage negative 25 volts and 2 volts and 25 volts plus 23 volts. The cathode without 1 is negative with respect to the anode. The 1 conducted from time 2 to time 3. The capacitor 1 quickly charged through the diode from 23 positive volts to 25 positive volts. Output voltage change again from negative 2 volts to 0 volts. At time interval 3, the input signal with the capacitor voltage with the again series 80 with the output voltage across felt across the resistor 1 and diode is again 50 volts during the time 3 and 3 over 4. The capacitor 1 discharge the 2 volts through the resistor 2 1. Note for the circuit operation time 3 and 4 with the same as wave for the time 1 and 2. The circuit operation of each square wave cycle cycle repeat the operation will occur within time 2 and 3. Sorry, time 2 and 4. Time 2 to 4. Compare the input wave shape with the figure 4A view B with the output wave shape of the note for the following important points. The peak-to-peak amplitude with the input wave shape that has been changed with the clamper circle with the shape of the output wave shape that has been significantly changed from that of the input action of the clamper circle with the output wave shape that is down above all 0 volts wherever the input wave shape is above below 0 volts. The lower port of the input wave shaper that has been clamped with the DC potential for the 0 volts output of the circuit is referred to as the positive clamper, since all the output wave shaper is above 0 volt at the bottom and is clamped at 0 volts. The positive clamper circuit is self-adjusting, meaning the bottom of the output waveform remains clamped at 0 volts during the change of the input signal amplitude. The output wave shaper retains form peak-to-peak amplitude with the 50 volts. In this case, the input wave shaper, the input of the amplitude becomes greater with the charge of the capacitor, becomes greater with the output amplitude, becomes larger. The input amplitude increases with the capacitor does not charge with the limit highs before the clamping occurred with the lower output volts of the capacitor charge, therefore to change the signal strength. The size of the resistor 1 and capacitor 1 is directly affected upon the operation of the clamper together. The smaller the resistance of the diode with the capacitor charge at the time of either resistor 1 and capacitor 1 made, but the smaller the discharge of the total time constant is equal to the resistor times the capacity. The ability of small value of the capacitor quickly discharge lower volts with advantage, with the amplitude of the input wave signal suddenly reduced. However, the normal clamping operation quickly discharge with the disadvantage. This is because the one object of the clamper is keep the output wave of the shape of the same with the input wave shape. If the small capacitor allowed with a relatively large amount of the voltage discharge each for the cycle of the distortion occur with the output wave shape with a large portion of the wave shape of the period with the wrong side of the reference frequency, increase the value of the resistor, and the discharge time is equal to, again, the time constant of the equal to the resistance time of the capacitor, but the increase of the value of the capacitor discharge more slowly produce output wave shape with which better reproduction input wave shape with the disadvantage increase the resistance over the wave resistance value with the larger resistance increase the discharge time of the capacitor show that the self-adjusted rates of the circle, the particular with the sudden decrease the input amplitude sure to occur with the large resistance has no effect with the self-adjusting sudden rise of the input of the amplitude, but this is because of the capacitor charge through the small resistance of the conducting diode. Circuits often incorporated with the compromise through the short resistance capacity, resistor capacity, and time consulting self-adjusting purpose with the L and RC time constant with the less distortion point with the reverse resistance of the diode, sometimes replaced with the physical resistor and the discharge capacitor of the capacitor. Alright, positive diode clampers with bias. We're going to cut the tape there.